Hello, good morning. Today I'm going to show you the video of solution of 5 problems taken from the conditional identities of trigonometry of addition and mathematics for grade 10. Okay, look at the question number 1. The conditions is a plus b plus c equal to pi radian, and then put that sine 2a plus sine 2b plus sine 2c equal to 4 sine a sine b sine c. So, and similarly, there is other problems. Before proving this, you must remember the formula of trigonometry, and the formula such as multiple formula, submultiple formula, transformation formula, and Pythagorean relations, and trigonometric ratio of any angles. All the formula you should remember. I assume that you remember that formulas. Okay, I'll write the formula which is used during solving this problem. Okay, let us start the solutions. So, in the given conditions, in 1, that is here, a plus b plus c equal to pi radian, and now a plus b equal to pi radian minus c, taking c to the right, because sine 2a, sine 2b, the first two terms contains a and b, so we write a and b to the left. Okay, so now taking sine on both sides, we get sine pi radian minus c equals sine c. Similarly, taking cos on both sides, then we get cos pi radian minus c, and this equals minus cos c. This is the formula of any ratios of 180, ratio of 180 plus minus theta. That is, in 180 the ratio remains same. Okay, and in second quadrant sine is positive, but in second quadrant cos is negative, so we write minus cos c. So now we start the left hand side. Start the solutions. We have a sine 2a plus sine 2b plus sine 2c. So using the formula sine c plus sine d for the first two terms of the left this sides, this equals to sine 1 by 2 c plus d times cos 1 by 2 c minus d. Okay, this is the one of the formula. Then using that formula we have 2 sine 1 by 2 2a plus 2b times cos 1 by 2 2a minus 2b plus sine 2c. Okay, this is formula that we have used. So now by simplifying this, we get sine a plus b times cos a minus b plus sine 2c, because we can take 2 common, and 2 and in denominator and numerator cancel, and we get this result. So now we use condition. Sine a plus b is sine c. Okay, so look at here. We have changed sine a plus b to sine c by using condition. This conditions, sine a plus b sine c. Look at here. Then we have to change this sine twice c. So this sine twice c using multiple angle formula, sine 2a equal to 2 sine a cos a. So by using this multiple formula to sin 2c, we get 2 sin c and cos c. So now 2 sin c, 2 sin c, we can take common 2 sin c, we get cos a minus b plus cos c. So now 2 sin c as a factor and of these two terms. Now cos a minus b, we have to find the remaining terms sin a and sin b. Sin c is already obtained. No, so now there is a minus b, but here is c. So what we do? We again use the conditions. Okay, look at here. Cos a plus b equal to minus cos c. Okay, so you can write that cos c is equal to minus cos a plus b. So we replace this cos c by minus cos a plus b. Again, 2 sin c. Now we have here cos a minus cos b and minus cos a plus b. And this is the formula of 2 sin, this is also known as transformation formula, 2 sin a sin b. And this equal to 2 to the 4. Now we write in a order of a, b, c. Angle a sin b and angle sin c. Okay. So 4 sin a sin b sin c. This is the right hand side proved. In this way, we proved the first problem. Remember this one? Okay. Now we prove the next. That is question number 2. So in question number 2, we have again the same condition, a plus c, b equal to pi radian. But look at here in the right hand side, we have to find a by 2, cos a by 2, cos b by 2, cos c by 2. But this is a. So first we transpose pi radian minus c and we divide both sides by 2. Because the right hand side of our condition identity is c by 2. Okay, a by 2, b by 2, c by 2. So we divide it. Now we take sine and cos both. Sine a plus b by 2 equals sine pi radian by 2 minus c by 2. And this equals cos c by 2. Okay. In the ratio of 90, the trigonometric ratio changes from sine to cos. And in first quadrant, all the trigonometry have positive values. So cos a plus b by 2 equals cos pi radian 2 minus c by 2, and this equal to sine c by 2. Okay, this is the conditions. Now we start the left hand side of this question number 2. Okay, what is in the left hand side? Sine a, sine b and sine c. And same as in the question number 1, we use formula of sine c plus sine d. Same formula, okay? Look at it, this formula. So 2 sine a plus b by 2. So, and cos a minus b by 2 plus sine c. And then 2 sine a plus b by 2. Look at here, it is cos c by 2. So we use it cos c by 2. Cos a minus b by 2 plus, now it is cos c by 2 and this is sin c. So we use submultiple formula of sin c. So we have formula that is sin c by 2 into cos c by 2. Sin c is equal to 2 sin c by 2 cos c by 2. So we have a common cos 2 cos c by 2. So we left now cos a minus b by 2 plus sin c by 2. Okay, so 2 cos c by 2. So now we break up this cos a minus by 2 b by 2 plus, and sin c by 2 is cos a plus b by 2. That is cos a by 2 plus b by 2. Okay, so 2 cos c by 2. Now look at here, cos a minus b plus cos a plus b. Since we know that cos a plus b plus cos A minus B equals to cos A cos B. This formula. So in place of A we have A by 2. So we can write here 2 cos A by 2 and cos B by 2. This by this formula. So this equals, writing in the order 4 cos A by 2 cos B by 2 cos C by 2. This is the formula, okay? This is right hand side root. Okay. So in this way we have proved 1 and 2. Now let us see in the question number 4. Okay, this question number 4 is related to this question number 1 and 2. I have designed in such a way that, okay, so in question number 4, what we have? We solve question number 4 instead of 3. We have in numerator we have sin 2a plus sin 2b plus sin 2c, and in denominator we have sin a plus sin b plus sin c. Okay. Look at it. The denominator can be changed to 4 sin a sin b sin c by this way. Similarly, the numerator can be changed to this form. Okay. Similar to this process. So you copy this and this. I start the one, solutions of question number 4 directly. This is the two procedures to obtain sign numerator and value of numerator and value of denominator. So we have a left hand side sin 2a, sin 2b, sin 2c. Then we have sin a plus sin b plus sin c. So you solve like this, all this, okay? Then you will get 4 sin a, sin b, sin c. And in denominator we get 4 cos a by 2, cos b by 2, cos c by 2. Okay. So now listen, 4, we have a submultiple form in the denominator and the normal form in the numerator. So we change that sin a into the submultiple form. So 2 sin a by 2 cos a by 2. And similarly for sin b, 2 sin b by 2 cos b by 2. And similarly 2 sin c by 2 cos c by 2. We have changed this numerator by this, and we have same as you can write this cancel or cannot, etc. 2 2 2 3 2s, 2 to the 4 to the 8, and forgot to write cos a by 2 cos b by 2 cos c by 2. So 2 2 2 2 to the 4 to the 8, and cos a by 2 and cos a by 2. Common factor in numerator and denominator, and cos b by 2, cos b by 2, cos c by 2, cos b by 2. All cancel by one time. So we have the three factors: sin a by 2, sin b by 2, and sin c by 2, which is the right hand side root. Okay. Yet proceed similarly, okay, for numerator and denominator, and then change. You get this result, okay, and after this after simplifying you will get the right hand side easily. Okay, this is the simplest method can do, though it is long, but the same similar type of problem we have to do twice. Okay, now we solve question number 3. Question number 3. Okay, let us clear this. You see this? Okay, question number 3. We have a given conditions a plus b plus c equal to pi radian. So it transfers a plus b equal to pi radian minus c. Now look at here, the right hand side, is pi minus a by 4, pi minus b by 4, pi minus c by 4. The angle is divided by 4, submultiple of 1 by 4. So we divide both sides by 4, a plus b by 4, pi radian minus c by 4. Okay, so then we have that sine a plus b by 4, not sine, we take cos pi a plus b by 4 equal to cos pi minus c by 4. Okay, pi radian minus c by 4. Okay, now we start the left hand sides. Look at the left hand side, that is cos a by 2 plus cos b by 2 plus c by 2. So one thing we do here is that if 0 plus is, we can add 0, because this adding 0 to something is something itself. So we can add 0. And then one more thing, we know that 0 is equal to cos 90 degree. Okay, so we replace that 0 by cos 90 degree. Cos 90 degree. Okay. Then now we use the transformation formula of CD, cos C plus cos D. You know that cos C plus cos D equals 2 times cos 1 by 2 C plus D times cos 1 by 2 C minus D. So by taking that formula to this form, we get, right like this here, 2 cos 1 by 2 C plus D, that is a by 2 plus b by 2 times cos 1 by 2 times a by 2 minus b by 2. Okay, similarly for the last two terms we use the same formula. Okay, I clear this here. 2 times cos c by 2 plus 1 by 2 times, okay, 1 by 2 times c by 2 plus pi radian by 2 times cos 1 by 2 times c by 2 minus pi radian by 2. So now look at here, to simplify all this, a by 2 plus b by 2, that's a plus b by 2, and 2 2s are 4. So we get here a plus b by 4. Similarly here a minus b by 4, and here 2 cos, I write pi at first, by 2 by 4, and similarly we can write here pi radian minus c by 4. Since look here, cos minus a equal to cos a, so this c by 2 minus pi by 2 can be written as cos pi by 2 minus c by 2. Okay, by taking minus common, we have the form minus a, and that minus a equal to cos a, cos minus a equal to cos a. So we have this result, and this is equal to pi minus c by 2. Okay, so we have further, cos 1 by 2, you write like this, cos 1 by 2, and this is equal to cos pi by 4. So we write cos pi minus c by 4 to this. Now we apply the condition. What is the condition that we have? Cos a plus b by 4 is cos pi minus c by 4. So we write here cos pi minus c by 4, cos a minus b by 4. We copy all the terms as it is. Cos. So now we have a common factors, that is cos pi minus c by 4. So we have got a minus b by 4 plus cos pi plus c by 4. Okay, after this we have obtained one of the factor of the right hand side of question number 3. Now we have to find the factor in terms of a and b. A and b, but here we have c. So we have to replace it. 2 cos pi minus c by 4 cos a minus b by 4 plus, and this c can be written as, look at here, a plus b plus c is equal to pi. So this pi plus c can be replaced as pi plus, the value of c is pi minus a minus b, pi minus a minus b. Okay, this term c from 1, because a plus b plus c is equal to pi. So c is equal to pi minus a. So this becomes 2 pi minus a minus b. So you can write here cos 2 pi minus a minus b whole divided by 4. Now we have only the terms containing a, b here. We have already obtained pi minus c. So now we use here the same transformation formula used in this case. So look at here, 2 cos pi minus c by 4 times, so cos c plus cos d, the formula is 2 times cos 1 by 2 c plus d, that is a minus b by 4 plus 2 pi minus a minus b by 4, and cos 1 by 2 c minus d, that is a minus b by 2 minus, you put the bracket, 2 pi minus a minus b by, that is 4. Okay, yeah, this is the closed. Okay, so cos pi minus c by 4, 2 2s are 2 2s are 4, you can write here 4. Now look at here, cos, adding these two fractions, so it is a plus sign, so there is no change in sign. That means a and a cancel out. So we have got that cos 1 by 2, 4 2s are 8, and you get 2 pi minus 2b, plus in the same way in this part 1 by 8, sorry, it is 4, okay, 4 4, when subtracting these two, so there is a minus sign, so this becomes plus, this becomes minus, and this becomes plus. Okay, so b and b cancel, then we get that cos 2a plus, sorry, 2a plus 2a minus 2 pi, 2a minus 2 pi. Okay, that's just the simplifications. 4, and look at here, 2 is a common from these two terms, and there is a 1 by 8, so it becomes 1 by 4 pi minus b. Similarly, taking minus, same reason, cos minus a is equal to minus a. So I have got that we can write this pi minus a. Similarly, as previous terms, 1 by 4 pi minus a. So arranging in the order of ABC, we get cos pi minus a by 4 times cos pi minus b by 4 times cos pi minus c by 4. This is the right hand side, and this completes the proof of question number 3. Okay, we left one more problem to solve. That is question number 5. And that question number 5 is similar to this question number 3. You look here, cos a plus b by 4 is equal to cos pi minus c by 4. Cos a plus b 4 can be replaced, cos pi minus c by 4, and same thing. Okay, so right here, question number 5. Okay, before you look at question number 3, all this procedure. Now question number 5, same procedure. Start, only you have to change here for cos pi minus a. Listen. You can write here, taking cos, if you take a to the right, then pi minus a, and dividing both sides by b plus c by 4 equal to pi minus a by 4. So cos b plus c by 4 equal to cos pi minus a by 4. Okay. So you can write here cos pi minus a is equal to cos b plus c by 4. Similarly, cos pi minus b is equal to cos c plus a by 4. And pi minus c is cos a plus b by 4. This is the right side of arranging in the order. You can see that for cos, same order. Yes, correct. This is the right hand side proved. Okay. So by these conditions, we can derive the another condition. Okay. Similarly, for another, taking c plus b to right, we get b, and therefore c plus a equal to pi minus b by 4, and therefore cos c plus a by 4 equal to cos pi minus b by 4. Okay, this is another conditions. Okay, you can go thoroughly this process. Okay, this complete the solution of 5 problem. Thank you for watching the video.